For this video, we're going to be discussing graphs of quadratic equations. So a quadratic equation is just an equation that has a degree of 2. So by a degree of 2, we just mean that the largest exponent in our equation is a 2. And this right here is what we call the general form of a quadratic equation. And it looks like this: ax squared plus bx plus c. Right, if you remember from our previous video that this is a quadratic trinomial, and anytime we work with a quadratic, we're going to want to put it in this form. And a quadratic equation can have a couple different types of solutions. It can have one solution, it could have two solutions, or it can have no real solutions. And we'll be talking about how we can figure this out from a graph in a little bit. So for this video, we're going to talk about the different features of the graphs of a quadratic equation. So this is the graph of a quadratic equation, and we call the graph a parabola. That's this U shape. We're going to talk about some sort of characteristics of this. First thing we're going to talk about, okay, these 2 points where the graph crosses the x-axis, those are the y or the x-intercepts. And the thing about the x-intercepts is that they also go by different names. Sometimes they'll be called the roots. Sometimes they'll be called zeros. And sometimes you're going to see them get called solutions. So what's important to know is that if you see any one of these 4 words, x-intercepts, roots, solutions, or zeros, they all just mean the exact same thing. All right, this point down here where the graph crosses the y-axis, that's the y-intercept. And then this low point down here is called the vertex. And it's where the graph changes from going, in this case, from going decreasing to increasing. And for this graph, it's the lowest point. For some quadratics, if I had a quadratic, for example, that opened downward, then the vertex would be the highest point. So other names you're going to see for the vertex, in this case, it is the minimum, because it's the lowest point. If it was the highest point, it could also be called the maximum. So it's kind of important to know these different vocabulary words for the features of a quadratic equation. The other thing to know about a quadratic that we can figure out from the graph is we can figure out some things about the leading coefficient. So the leading coefficient, that's just the coefficient on the x squared term. And that leading coefficient determines whether the graph opens upwards or downwards. So here I've got a graph that opens upwards. So our 2 arrows at the ends of our graph are pointing up. And in this case, a is going to be a number bigger than 0. A is, in other words, positive. And a positive leading coefficient makes the graph open upward. In this case, I've got a parabola that opens downward, and a parabola that opens downward is going to have a leading coefficient less than 0, so it's going to be a negative leading coefficient. All right, so you can tell that just from looking at the graph, like, oh, it opens up, positive leading coefficient, opens down, negative leading coefficient. All right, so some other things we can do is we can use the graph of a quadratic to find the number of solutions. Okay, remembering that solutions, x-intercepts, zeros, and roots are all the same things. So we have 3 possible options for the number of solutions. We can have exactly 1 real solution. So that's where there is 1 x-intercept. The graph touches the x-axis exactly 1 time. We can have 2 real solutions, where the graph has 2 x-intercepts and touches the graph in 2 places, or we can have no real solutions where the graph does not touch the x-intercept or the x-axis at all. It has no x-intercepts. So we can look at the graph and use that to determine how many solutions there are. Now, one thing we do want to take a look at is a graph that does not touch the x-axis, so a quadratic that has no real solutions. What it is going to have complex solutions. So if you remember from a previous video, complex numbers are numbers like this that have an I in them. And so, for example, in this graph, this is the graph of negative 2x squared minus 1 equals 0. Or we can also call it y equals negative 2x squared minus 1. And this graph has no real solutions. It doesn't intercept the x-axis at all. But it does have two solutions. All right, these two, negative I square root of 2 over 2 and positive I square root of 2 over 2. But the thing that's important to know is that these cannot be found by graphing. So we have to do a different method to figure these out. And that's a method we'll talk about in a later video. So going by what we know now about the different characteristics of a quadratic equation, let's go ahead and fill in these characteristics of our graph here. So first question is the vertex. First off, if I look at this, I want to say that our vertex is a maximum. And the coordinates of it, it's right here at negative 2, 4. So this graph has a maximum of negative 2, 4. That's the vertex. For the solutions, remember the solutions are the x-intercepts. So our two solutions are negative 4 and 0. The leading coefficient, well, if I look at this quadratic, this parabola opens downward, so I might know that my leading coefficient is going to be negative. And then domain, range, and end behavior, these are some carryovers from a previous unit, but they're things we still want to be able to do. This graph has arrows on it, we just don't have them drawn in here. This graph goes forever in both directions. So the domain, I've got an arrow pointing left, that's negative infinity, and an arrow pointing right, that's positive infinity. So my domain, negative infinity to positive infinity. For my range, on the low end, the graph goes down forever, so that's negative infinity. But this graph does have a highest point up here at negative 2, 4, so the y value there is 4, so my range is negative infinity to 4. For the end behavior, if I look on the right side, my graph is going forever to the right, so x is going to infinity. And as I go to the right, I'm going down forever, so y is going to negative infinity. On the other side, once again, x is going forever, so that's negative infinity. And y is going down forever, so that's negative infinity again. So this is how we can use the graph to fill in these different traits. Let's look at a second example. Example 2, same thing. We want to fill in the characteristics. So the vertex. This one has a minimum right here. So this has a minimum. And that minimum is at 1, 3. For our solutions, this graph does not intersect the x-axis at all. So the only thing I can say, I can't use my graph to find the solutions. So what I need to say is that this graph has no real solutions. And notice I'm not just saying that it has no solutions at all. It does have solutions. They're complex. I just can't figure them out from the graph, so I'm going to say no real solutions. This graph opens upward, so its leading coefficient is positive. If I think there are some arrows here, so my domain, I'm going forever to the left, forever to the right, so my domain is negative infinity to positive infinity. In fact, all quadratic equations have a domain of negative infinity to positive infinity. My range, this one has a lowest point at y equals 3, so my range is from 3, and then I have arrows going up forever, so it's to infinity. For my end behavior, well, as I go to the right, x goes on forever to the right, so that's infinity, and it's going up, so y is also positive infinity. To the left, x goes on forever, so infinity, and y also goes up forever, so that's positive infinity. All right, so now you know some traits of quadratic equations, so I'm going to leave you with this try it problem. You need to just fill in the characteristics of this graph.